Okay, we're live. Welcome to another Nerd Stalker interview. Good morning. This is Greg Gloria, aka Social Greg on Twitter for the Nerd Stalker Media Network. Today we'll be talking with Abdullah Rauf. It's the Senior Product Marketing Manager on the Lattice Hackathon called Small FPGAs and Big Possibilities using their FPGAs. And we'll have him talk a little bit about that if you guys don't know that. And it's targeted towards makers. And so the Nerd Stalker channel is really geared towards a lot of maker events. We attend Maker Fair every year here in the Bay Area, and we're grateful to have the opportunity to promote an event for makers like this. So anyway, a little bit of Abdullah. He has more than a decade of experience in the semiconductor industry and product management, and holds a degree, electrical engineering degree, from UC Davis, great school, and an MBA from local, great MBA program, University, Santa Clara University, and they do a lot of entrepreneurship things there, and it's a great place, actually. I have a lot of friends who've graduated for that. Anyway, good morning, Abdullah. Thanks for joining us live from San Jose, right? Lattice Semiconductor, right?
Yep, good morning, Greg. Thanks for having me.
Oh, no problem. I appreciate that. So, let's start this off. I think, when you look at the acronym FPGA, I don't know if everyone really knows that. So can you kind of describe what FPGAs are for the audience and kind of, walk us through that a little bit?
Sure. So FPGAs stand for Programmable Gate Arrays. So what they are is you have many gate arrays or logic blocks that can be configured in many different ways. For example, you can have a block act as a flip-flop, as a finite state machine, as a multiplier, as an accumulator, as you can probably implement FFTs, FIR filters, or you can implement simple AND gates or OR gates. And again, there's multiple blocks, hundreds of blocks within a single FPGA. Now you need to interconnect each block. And that's also very flexible on how you interconnect them. And as you start interconnecting them, you can build complex solutions. And the biggest value of an FPGA is that each block that I mentioned earlier can compute a part of your algorithm or whatever you want to solve. It can compute it in parallel. So that's the biggest difference between microcontrollers and FPGAs. Microcontrollers are time limited. They have a frequency, a clock, and you got to run every computation in series. So, and if you want to run it faster, if you have a lot of computational requirements, you got to just run that clock speed very, very quickly, which means you're going to consume a lot of power. In FPGA, you have hundreds of blocks. Each block can do everything simultaneously. That means everything is done in parallel. That means your clock speed is going to be 1/100th of an MCU clock speed. So we've actually done a lot of analysis comparing ourselves with MCUs in terms of power consumption. And in certain situations, we're 70% less power consumption in a microcontroller. Yeah, that's our biggest value.
I never thought about that, actually. Now that you brought it up, is that you're really at the gate transistor switching speed. Right? Can't get any faster than that, right?
Exactly, yeah.
That's amazing. Yeah, I never thought about that. So boil it down to a maker maybe starting out with microcontrollers, and I think that's a big value, but maybe kind of talk about how FPGAs are used in the real world a little bit, and kind of give the makers out there a kind of an idea of how they could, the possibilities of this.
All right. So if somebody's very familiar with microcontrollers, that means they're very familiar with C programming. That's the language you program microcontrollers in. And the instruction sets, as everybody knows, is very serial. If you want to program an FPGA, it's going to be a different language. You're going to have to use like a hardware description language, VHDL, Verilog, RTL. It's a lot lower level, a lot more complex. It's different than C, and it's more, again, parallel type of execution requirements. So you're going to have to write your programs differently. And a lot of people, what they call FPGA blocks, they basically call it a bunch of femtocontrollers. So they assimilate the FPGAs into, again, hundreds or thousands of little small femtocontrollers, and each one controlling a specific finite state machine. And your finite state machine can do different functions. Like one of them can control your memory, one of them can control your ADC, one of them can control something else. So in your system, you can have a bunch of little controllers. So if a developer is going to pick up an FPGA for the first time, what I would tell them is try to understand the a hardware language versus just your C code. That's going to be your biggest difference. And actually, there's some FPGAs, even Lattice's FPGAs, that have been demonstrated with soft core. Yes, so that means you can actually write in C and program the FPGA to do what you want it to do. So there was a conference at MIT in July of this year. And there was a company that demonstrated a Lattice FPGA, and they put a RISC-V processor inside of it. Wow. And they were able to have instructions in C, which a lot of developers are very familiar with, and they were able to make use of the parallel functionality of the FPGA. So if developers are really afraid or not really knowledgeable on HDL kind of languages, there are some workarounds, there are some ways to still use C, but if you want to get the true value of an FPGA, you got to learn that HDL language.
Well, and you bring a very good point, because a lot of the makers out there are hobbyists, but I think more and more of these hobbyists are really developing some pretty cool solutions out there, and they'll hack around and they'll get it. But are there resources besides, do you guys have a resource on your site where you could actually start to explain how the programming languages work and stuff like that?
Yeah, so we have our own tools. Our own basically IDE development environment that you can program our FPGAs. And yes, we have some tools, some tutorials on how to kind of start off. We have some example code that we can give to you for free, to any of the developers for free. They're on our website. Just hundreds of reference code that we have available. And then we have live tech support as well. If you have some questions, go on our website. There's a tech support button, and you can ask some questions, and we'll be happy to help you out.
Oh, that's cool. Well, let's shift to the fun part here. Let's talk about this hackathon that you guys doing. Can you talk a little bit about that, Abdullah?
All right, so this is going to be Lattice's first hackathon, so I'm very excited about it. We're releasing hardware to the developers, so that means we're going to give you free boards to play with. Yes, we're giving free boards. So microcontrollers are become very popular with the Adreno type boards. We have our own type boards that has a bunch of header pins. You can connect different connections to it. You can have different functionality. You can program and do whatever you want. Those are the boards we're going to give you for free. And we have about, I want to say, 10 to 20 different boards you can choose from. Right? So you're not going to be limited to one functionality or one type of board. We have a wide array of different boards. We're going to give you that to you for free. And if you have the winning solution, you're going to get $5,000 cash. The top 3 teams get a free trip to Las Vegas.
Wow.
During CES, and as you know, CES is the largest electronic consumer show in the world. And the top winner, the number 1 guy, is going to be able to demonstrate their solution at CES, get tons of press coverage, and possibly get some funding out of it. I don't know, maybe he might meet the right person. There's a lot of people at CES you might want to meet with.
No, I think you're absolutely right about that. I think there's a lot of VCs, angels, people who just want to see some interesting solutions come to market, right? So what you guys launched it last week, right? And when's the closing date for submissions?
So there's 2 levels of submissions. The first level of submission is we just want to know who your team is. Tell us about your team. Tell us your background. What experience you have with programming microcontrollers? What experience you have programming FPGAs? We want to know both. That's September 30th. And then the second level of submission is going to be, tell me exactly what you're going to do. What is your product that you're going to develop or a solution you're going to solve? What boards you want. Remember I told you we have about 20 different boards? You got to tell me which boards you want. You get up to 3 for free. And then you also have to describe how are you going to demonstrate it once the solution is available. That's going to be due in October. Then the final solution is going to be due December. I think week of December 12th is going to be when the actual solution is going to be finally judged on, and we're going to choose the top 3. And then the winning guy is going to demonstrate it at Las Vegas first week of January.
Wow, that's going to be a fast trip for this. So how does the judging work? Is there any criteria you want to give the audience a little bit of help on what you think you guys might be looking for, or stuff like that?
So the number 1 requirement is it has to solve a mobile problem. Okay, so that means a battery-powered application. Batteries are found in so many different devices. So that's number 1 rule. Number 2 rule is we want to find something that's creative that hasn't been solved before. So something that you cannot solve using a microcontroller. Remember, the biggest value of FPGA is parallelism. If you have a lot of repetitive computation that needs to be done, you want to do that in an FPGA. So I'll give you some examples. Maybe some facial recognition. So you want to detect and calculate the edges of your face, the distance between your eyes, the distance between your nose and your mouth. All this requires computation, and you want to compute it very quickly. All of this that I just mentioned a second ago has to be computed at the exact same time so that you can match the face. That'll be a great solution. Gesture recognition. You want to make a snap, do something in front of a camera. You want to have your finger, if you go like this, maybe volume will go up. You want to be able to detect what's happening with your finger. That's another solution that FPGAs could solve. That'll be a great solution. Audio beamforming, voice recognition, pattern recognition. I mean, there's a long list of solutions. So battery powered, use the repetitive computation requirements, and get creative with it. So show me something that hasn't been solved before.
No, that's cool. No, I guess you guys will be going after RealSense a little bit, huh?
Somewhat, yes. We're actually working with them, so I'll tell you. I like the technology of RealSense, and it's a great technology.
No, I've seen some interesting use cases. I was just at the J-Pop Expo, and this Japanese company integrated into their laptop, and it allowed you to actually to create music with gestures and stuff like that. But I think you bring up a very good point. I mean, something that needs to be done quick and in parallel. The FPGA will be the fastest solution. I mean, like you said, you can't get any faster than the gate speed of the switch. Which, if you think about it, you are limited to clock speed on the microcontrollers, microprocessors. So that's great. No, that's good. I appreciate you kind of introducing this thing. One question I had was, is the judging panel made up of Lattice Semiconductor people, or is it a general panel of makers and people, or what composes this judging panel of yours?
Yeah, the judging panel is going to be Lattice employees. It's going to range from field application engineers. We have some marketing guys, some members of our CTO office, and we also have marketing communication. So they're going to be able to kind of see what is the message that's being delivered, what is the value proposition that's being delivered. So it's a wide range of people on this panel.
Yeah. No, I mean, you guys have been around. Yeah, no, it's good. You guys have been around a while, so I'm sure there's a lot of experts in that area. Okay, well, we'll close off the interview. I appreciate you spending some time with us, waking up early and getting into Lattice Semiconductor in San Jose there just to have this interview.
No worries.
But how do people get to know more about this hackathon and get a hold of you maybe?
So go to our website, latticesemi.com/hackathon. And you'll be able to find out where to ask questions, how to submit your application, find out all of the rules, and find out all of the tools available for you if you want to jumpstart something.
No, that's great. And, we look forward to promoting this on NerdStalker and getting the word out to the maker community. So, and again, I really appreciate your time there and hope that, this becomes successful and people could use FPGAs. Normal people like makers could use FPGAs. So appreciate it. So anyway, that was Abdullah Rauf of Lattice Semiconductor. And he's really promoting this hackathon and, not in a they're not going to lock up people for about 24 hours, but it's going to be a long-term thing. And it's a contest. So, he all the information is there on the website that he just provided. And, anyway, I really, again, appreciate your time. So anyway, that was Abdullah Rauf of Lattice Semiconductor, and you can find out more about the hackathon on our blog. And you can visit www.latticesemi.com for more information on not only the hackathon, but their products. They have some great products. So anyway, thanks for joining us, everyone. This is Greg Valoria, AK Social Greg, on Twitter for the NerdStalker Media Network, where we believe in tech, startups, design, and you. Thanks for joining us, everyone, and be careful out there. Anyway, thanks, Abdullah. Have a great day, huh?
Bye, Greg.